Hello everyone and Assalamu alaikum. I welcome you all in this project. In today's project, I am going to present my latest project which I built from scratch using Python and NumPy. This project is extremely important for anyone who wants to learn machine learning. Before going too deeply in this project, I am going to first discuss that what is machine learning. Machine learning is a branch of artificial intelligence where a computer learns patterns from data instead of being programmed with fixed rules. In traditional programming, we write the rules by ourselves. Like for example, if both switches are on, then return 1. Here, the programmer already knows the logic. However, in machine learning, we do not provide the rules. Instead, we provide examples. The machine studies these examples and automatically discovers the rule by itself. This is the main idea behind machine learning. Now, what is a perception? A perception or a perceptron is the simplest machine learning model used for binary classification. Binary classification basically simply means making one of two possible decisions. For example, yes or no, or true or false, or spam or not spam, or 0 or 1. The perception was introduced by Frank in 1958. Today's modern deep learning models are made up of millions or even billions of neurons, but everything started from the single perception or perceptron. Biological neuron versus artificial neuron is a very interesting topic in my this project. Let's compare it with human brain. A biological neuron receives signal from other neurons, processes the information and then sends an output in the form of signal. Similarly, an artificial neuron receives inputs, performs a mathematical calculation and produces an output. This process is very simple and the entire process is called the perception or perceptron. Basically, the objective of this project is very simple. We want our perception to learn different logic gates. Instead of writing logical rules manually, we want the machine to learn those rules from examples. Now, what are logic gates? Basically, logic gates are the basic building block of digital electronics. Every computer's processor contains millions or even billions of logic gates. Some common logic gates are AND or NAND, NOR, XOR, and XNOR. For example, in case of AND gate, 0 into 0 output will be 0, 0 1 output 0, 1 0 0, and 1 1 the output will be 1. Basically, the AND gate produces an output of 1 when both inputs are 1. Otherwise, the output is always 0. Or if I discuss OR gate, the OR gate is slightly different. The output becomes 1 whenever at least one input is 1. Now let's move towards the perception lab and my full this project. Here the configuration starts from the left side of the project. The left side of this project is called configuration panel. This is where we control the entire training process. Before training the model, we first choose all the required settings. The first parameter is selected logic gate. This is the parameters. Here we can choose which logic gate we want to train. Available options are AND, OR, NOT, NOR, XOR, and XNOR. In first case, let us select AND gate. As soon as we change the selected gate, the training data set changes automatically. For example, if we select AND, the perceptron learns the AND truth table. If we select OR, it learns the OR truth table. And if we select XOR, it attempts to learn XOR. But because XOR is not linearly separable, the perceptron cannot learn it perfectly. For in case of AND gate, Output is 1 only and only if both inputs are 1. The next parameter is learning rate. Learning rate controls how much the weight change after each mistake. If the learning rate is very small, the model learns slowly, and if the learning rate is too large, the model may become unstable and keep overshooting the correct solution. Basically, a balanced learning rate allows the perceptron to learn efficiently. The next parameter is epochs. The next An epoch means one complete pass through the entire training data set. For example, the AND gate has 4 training samples. If the perceptron processes all the 4 sample ones, this is one epoch. If it is processed then 10 times, that means that 10 epochs, and higher epochs gives the model more opportunities to learn. And here I use advanced options as well. Random weight initialization. Before training begins, the perception need initial values for its weight. And the next is show decision boundary. When enabled, the project displays the decision boundary after training. The decision boundary is simply the line that separates one class from the another. This visualization helps us to understand how the perception is making its decision. Train perception button. When we press the button, the complete training process begins. And here the dataset information are also used here in this project. So let's start with it by clicking the training perception button. Yes, truth table. In the right side, we see the truth table. It contains input 1, input 2, and the correct output. For the AND gate, the truth table is 000010. As you see, guys, in my project, the perception studies these examples one by one during training. Predictions. Here in the right side, guys, you see predictions. After training, the project displays the predictions table. The table compares the actual output with the predicted output. If both values match, the prediction is correct, and if they do not match, the perception made a mistake. This comparison allows us to evaluate how well the model has learned. In the middle, accuracy. Accuracy measures the percentage of correct predictions. The formula is predictions divided by total multiplied by 100 with predictions. The next one is final weight. For example, let us discuss accuracy more. If all 4 predictions are correct, the accuracy becomes 100%, and if 3 predictions are correct, the accuracy becomes 75%. Higher accuracy means better learning. Final weights. The next the project displays the final weights. During training, the weights are continuously updated. At the end, the product shows the final values of weight 1, weight 2, and bias. These will represent everything the perception has learned from the dataset. Bias is another important parameter. Without bias, the decision boundary would allow pass through the origin. Bias allows the perception to shift decision boundary. Training information. The next section is training information. Here we can see total epochs used, final loss, and conversion status. For example, if the model converges in only 9 epochs, it means the perceptron successfully learned the pattern before reaching the maximum number of epochs. Loss measures the total error made by the model. If we see our predictions and our truth table, it correctly matches our output. So guys, you see in our original truth table, both parameters are similar. I correct predictions 4 out of 4. So the precision learned the gate perfectly. Now let's move towards the visualization section. The first graph is training loss graph. The training loss graph shows how the loss changes during training. The horizontal axis represents the epochs and the vertical axis represents the loss. At the beginning, the loss is usually high. Look at the peak of the edge, it shows the highest percentage of loss because the model has random weights. As training continues, the perception gradually learns and the loss decreases. Finally, when the loss reaches zero, the model has successfully learned the dataset. The next graph which I used is decision boundary graph. The graph shows how the perception separates different classes. The colored region represent different perception areas. The line between these areas, is called decision boundary. For linearly separable data sets such as AND or OR, the perceptron successfully finds a straight line that perfectly separates both the classes. So it is all about my whole project. If I used to explain one of the important concept I used in this project, which is linearly separable concept in this project. A data set is called linearly separable if one straight line can perfectly separate both the classes. So if we look at our AND gate, the points are 0, 0, 0, 1, 1, 0, and 1, 1. If we plot these points on a graph as shown in this figure, red blocks represent zeros and green blocks represent class 1. Notice something interesting, guys. A single straight line can separate the positive class from the negative class. This means the AND gate is linearly separable. Since the gate is linearly separable, a single positron can successfully learn from it. So basically, linearly separable is a straight line can separate both the classes in it. Another example, if we consider the OR gate, let us move towards the OR gate, and if I train Perceptron, one straight line is enough to separate class 0 from class 1. Therefore, the OR gate is also linearly separable. And in this project, 4 gates are linearly separable and or NAND or OR are also separable. And if I choose XOR in this project, look here the options are non-linearly separable. And if we train our perception, the accuracy is also 50%, looking still learning, and the perceptron is struggling. Check if the gate is linearly separable. Yes, the gate is linearly separable because the positive points are placed diagonally. These the negative points are also placed diagonally. Now drawing a straight line, no matter how you draw the line, at least one point will always end up on the wrong side. Therefore XOR is not linearly separable in this my project. Now let's move towards the code section, and the last understanding the results. Here are also the results options is also shows in this my project. If I move towards the code section, here the code section is the code section of my project. Basically I use three type of NumPy concepts in this full project. The first one is random weight initialization. The perception needs some initial values. 1 minute, guys. Now, so this is my whole project code. The first concept is random weight initialization. The perception needs some initial values for its weights. Instead of assigning fixed values, we initialize the weights randomly. This gives the model a neutral starting point and allows it to learn from the training data. For example, in this code snippet, I use random concept in this code snippet. Here, the np.random function generates random numbers from a normal distribution. Input size decides how many weights are needed, and 0.01 makes the random values very small, which helps the model to start training smoothly. The next project is dot product. The perception combines the input features with their corresponding weights to calculate a weighted sum. This mathematical operation tells the model how strongly each input contributes to the final decision. Here, in this code snippet, I use the concept of dot product in it. np calculates the weighted sum. After the dot product, the bias is added and the result is stored in a variable z. The next concept is that I used is activation function. After calculating the weighted sum, the perceptron applies an activation function. In this project, we use the step activation function. Its job is very simple. If the weighted sum is greater than 0, the output becomes 1. Otherwise, the output becomes 0. Here, in this code snippet, I use the concept of activation or activation function in it. Code snippet is if z is greater than 0, then output will be 1. Otherwise, the output is 0. The function receives the weighted sum z, it checks whether z is positive or not, and finally it returns either 0 or 1. And at the last is array operations. NumPy is designed to work with arrays efficiently. Instead of processing one value at a time, it performs operations on the entire arrays simultaneously. This makes the code shorter, faster, and more efficient. In this project, arrays are used to store inputs, weight predictions, and great importance of visualization. So guys, it's all about the whole project, and at the last I use also the concept of broadcasting. It allows NumPy to automatically perform operations between arrays and scalar values without writing the loops. Thank you guys. Thank you so much.